Paper 52, June 2025. You have the first question that Rachel is throwing 3 coins. You're given that in the first coin, the probability of obtaining a head. So I'm going to write it like the PH1, which is head in the first coin. You're given that it is 1/3. If P in H1 is 1/3, then P in T1, remember that total probability is always 1. If the total probability is 1, which means that if this one is 1/3, this one would be 2/3. For the second coin, you're given that the probability of obtaining a head. So I'm going to write it PH2 is equal to 1/4. The same way as we did PT1, then PT2 would be 1 minus this, you're going to get 3/4. You're being told that the third coin is fair. Fair means that there is equal probability in both of them. So P of H3 and P of T3 will be equally the same. So I'm just going to take 1 and divide by 2. I'm going to get half here and then half here. These probabilities are important because once you draw your probability distribution table, you're going to use these values. Look at this. So I'm going to take my value of X. What you did here is correct, but what you missed is you have to focus on the number of tails. So the number of tails I can get 0, I can get 1, 2 or 3. So probability X equal to X. What happens if I get 0 tails? To get 0 tails, I must get head in the first coin, head in the second coin and head in the third coin. So H1, H2, H3. If I'm going to look at the probabilities, it will be 1/3 times 1/4 times half, which would be giving me 1/24. So in my probability table, this is 1/24. Then I'll calculate P3 because this is the easiest one to calculate. T1, T2 and T3. I get 2/3 times 3/4 times 1/2, and when I multiply all this, I get 6/24. For the time being, I put it like this in my table. Then I calculate either one of these two. Let me take P T1, this one, X equal to 1. X equal to 1 means I get only one tail. How do I get one tail? These are my possibilities. T1, and then if I'm getting T in 1, I will get head in the second one and head in the third one. Or I get head in the first one, tail in the second one and head in the third one. Then my last possibility would be head first, head second and then tail third. The probabilities are T1 would be 2/3 times H2 1/4, H3 is 1/2. Then it will give me 2/24. The same way I calculate the second one. P of H1 1/3, P of T2 would be 3/4 and P of H3 is half. I get 3/24. Then for the last one, H1 1/3, H2 1/4 and then half, it becomes 1/24. Then I'm going to add all of this. 3 plus 2 is 5 and 1, 6/24. I put it in the table here. To get the last one, I'm not going to calculate anything. Remember that total probability has to give me 1, which means that I just add them. 1 plus 6, 7 plus 6 is 13. 24 minus 13 is 11, which gives me the probability here would be 11/24. That's it. For the next question, this is correct. You're going to do an approximation. Your values for your mean and your variance is correct. What is incorrect is your approximation here. Usually, if you're going to do probability X greater than 120, you're taking a binomial and you're approximating to a normal. You can't take the same values because there will be anomalies which will be forming in the question. What happens is if you're going to take probability X greater than 120, usually you have these types of approximation. You have to change your values. So what happens if you're going to take 120 greater than this? You're not going to take 120 as your value. You're going to take 0.5 greater than this. It would be 120.5. So it will be probability x greater than 120.5. Then you're going to get probability z greater than 120.5 minus 112 divided by square root 33.6. You're going to get probability z greater than I think from my calculator I'm getting 1.4664. I think you have to do free 2 dp free dp only, sorry, 1.466. Then here, what is probability z is greater than 1.466? If you're going to look at your normal approximation graph, this here represents 0.5. So greater than 1 point, I think this represents 1, sorry. So greater than 1.466, 1.466 would be this probability here. But from your table, you can only get values that are this side. Then what you're going to do is you're going to take 1 minus probability z less than this, which will give you 1 minus phi of 1.466. This you read from the table, and you're going to get the value to be, I think, 0.9287, and your final answer. This approximation is very important because let's say if you're getting, let me remove this, if you had probability let's say x greater or equal to 120, so what happens is, again, you put 120 here, 120.5 after 119.5 before it. When you're taking 120 greater, because this 120 is included in it, we're going to go one step less, because it is already included. So this one would be probability x greater than 119.5. This is the difference between greater and greater equal to. If you had probability x greater than, let's say, 45, you're going to draw a number line. 45, you take 45.5 and 44.5. 45 greater than this 45 is not included, so definitely you're going to go afterwards, you're going to take this one, 45.5. That's how you do it. You can draw a tree diagram for this question because it tells you that you have two draws. Either you get a blue marble or you get a red marble, and then you get a blue and a red, or a blue and a red. This is your first draw. It tells you that there are 4 blue marbles, so this would be 4 over 16 because the total is 4 plus 12, which gives you 16. For the red marble, it would be 12 over 16. What's important here is that if one marble is selected as blue, it is replaced, which means that if I take one from here, the blue one, I'm going to put it back. Let's say from the 4 marbles, I take one, I'm going to put it back. So in my second draw, for my blue marbles, there will be no change because I will put the marble back, so the probability will be exactly the same. But what happens with the red is that if you take a red out, I have 12 red. If I take one out, in my second draw, I will not replace it, which means that out of 12, if I've taken the red, there will be only 11 remaining. And remember that I've taken only one red, which means the total itself would be decreased by 1, 11 over 15. What will happen to blue now? Blue will stay the same because I've picked a red. Blue will stay 4 over 15. Blue will stay 4 actually, but I have to put the total on 15. It's asking you what is the probability of obtaining the same color. So it would be probability of obtaining blue, blue, plus probability of obtaining red, which is correct here, but your values are not correct. For blue, this is my blue. I take blue here and then blue here. It will be 4 over 16 times 4 over 16 because I have replaced it. Or if I take a red, it's 12 over 16. But then the red is not replaced, which means that it will be decreased by 1. The total will also be decreased by 1. And when you calculate this, I think you're going to get 49 over 80, and that's your answer. The second question is asking you find the probability that the first marble is blue given that the second marble is red. Your presentation is correct, so it's P blue intersection red divided by P of red. But what does blue intersection red means? Means that it's getting a blue and then a red. Where do you get a blue and a red? Here 4 over 16 and then 12 over 16. So on top you're going to write 4 over 16 times 12 over 16. Probability of obtaining the second one red. To get the second one red, I can get either probability the first one is red and the second one is red, or I can get first one red and first one blue and second one red. What is probability red plus probability of blue red? You're going to do red would be 12 over 16 times 11 over 16. You're just going to follow 11 over 15. You're just going to follow the probability distribution tree diagram, not probability distribution table, the tree diagram. So this would be probability red, probability blue red, so I get the first one blue 4 over 16 times second one red, so I follow the same line. This is blue, the red is 12 over 16. You can simplify this. 16 into 12 would be 3 over 4. 3 into 15 would be 1 over 5. This into 12, again 3 over 4. 4 over 4 is 1. You get your calculator to do all of this. You're going to get this one would become 1 over 4, 3 over 16 divided by, you add these two, so I think it's 11 over 20 plus 3 over 16, and simplifying you're going to get your answer. I could have made a mistake, but your answer should be 0.254 as your probability. If you draw the tree diagram, you can follow directly from there. There's no need to calculate all this by yourself.